Hello, I'm Matthew, and the topic I'll be talking about today is distance in 2D and 3D and internal division point. So, what exactly is distance in mathematics and dimensional geometry? Distance is a quantitative measurement of the space between 2 points, and mostly in math, we talk about the minimum distance between 2 points and locations. And in Euclidean geometry, the minimum distance between two locations is the linear segment that connects point A and point B. So that would be the distance in mathematics. As you can see in the image here, A and B, and the distance is unknown. Let's first dive deep into distance in 2D. And when dealing with distance in two-dimensional space, we have to think and use the coordinate plane that most of you will be familiar with. And the formula for distance in a coordinate plane and the distance between 2 points x1, y1, and x2, comma y2 is the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is the proof of the distance formula. We can use the Pythagorean theorem and talk about it easily. So the distance between, let's not say distance, let's say the difference between the x value of q and p can be said as x2 minus x1, and then the difference between the y values of q and p is y2 minus y1, and that forms a right triangle, as you can see over here. So we can say that x2 minus x1 squared plus y2 minus y1 squared is equal to the square of the distance between p and q, which is the line segment PQ. And since we're finding the distance, we have to put a square root on that value, and that gives us the formula. And this is distance in three-dimensional space, and it takes place in a hyperplane, which is a three-dimensional plane with the x, y, and z axes. And the formula for the distance in three-dimensional space it's identical to the formula in two-dimensional space, but it combines the z values of the coordinates. Let's see the proof for that. This is just the same. Well, we first have to find the length of Pn here in this image right here. And Pn is just the same proof for the distance formula in 2D because it only deals with the x-axis and the y-axis, as you can see here, the x and the y. So that's just the square root of x2 minus x1 squared plus y2 minus y1 squared. But then we also have to take into account the length of Qn. So, and Qn is just a vertical measure that takes parallel to the z-axis. So we can just say it's z2 minus z1. So when we're finding the distance between p and q, we have to put that z2 minus z1 value into the original formula that we used to find the distance between p and n, which gives us the formula. And this is an example between point A, 6, comma 8 and the origin. And the origin is 0, comma 0, right? As all of you know. And the distance formula is right here. So you can just substitute in the values. So we substitute 6 for x2, 0 for x1, 8 for y2, and 0 for y1. And that gives us a formula. And when we evaluate it, we get 10. So the distance between the points is 10. And the internal division point is a certain point situated on a line segment such that the point itself divides a segment into the ratio m to n. It's pretty straightforward. And this is a formula for the internal division point, and I want to say the formula is just the notation, and it's notated by the star over here, which is mx2 plus nx1 over m plus n, comma my2 plus ny1 over m plus n. This is the proof, and this is just dealing with the x-axis, so it's a comma h for point A, x comma y for point P, and b comma k for point B. This is just you multiply m, and that gives you this proof. I wouldn't. I don't want to go over it for now because it's quite it's quite straightforward itself. You can just read through it. And this is the example. Consider the following 2 points: A negative 1 comma 2 and b 2 comma negative 3. Find the point which divides AP internally in the ratio 1 to 3. And the formula is here, and we have to divide A and B so that AP to B PB is 1 to 3. So for AP and PB, we can just substitute in the values. M is 1 and N is 3, obviously, and negative 1 for x2, 2 for x no, 2 for x2, and negative 1 for x1, and then we can say negative 3 for y2, and 2 for y1. And then we get the formula, and that evaluates back to negative 1 over 4, comma 3 over 4. Thank you. That was my video, and thank you for watching.